Okay, so college trigonometry students, we're going to be looking at today the solutions to this review that I gave you for exam 2. Okay, so exam 2 has two parts. It's going to have a calculator part and a non-calculator part. The non-calculator part should be something that you would want to spend probably around an hour on that, but not more than an hour. And then the short calculator part would be maybe 15-20 minutes. Kind of budget your time like that. All right, there's no notes and there's no identities. I don't give you any identities on this test. So you want to be sure that you're solid with all the identities that we've learned up to section 8.5. Okay, so to begin with, this problem number 1, what this is saying is you're on this interval. What values of x would the cotangent have a vertical asymptote? Now, you don't want to memorize this. I see students try to memorize stuff like this all the time. You want to reason this out. So I'm going to draw just a coordinate system and show you how you would reason this out. Okay, the thing is, the cotangent is x over y. Okay, so if we want to figure out where there's a vertical asymptote, the question becomes, where is y equal to 0? Okay, so basically if you look at this point on a unit circle, that would be the point 1, 0. And if you look at this point on the unit circle, that would be the point -1, 0. So this is 0 radians. And this, of course, is pi radians. Okay, so the answer to that would be x equals 0 and x equals pi. Those would be two places where a cotangent would have a vertical asymptote. Okay, and that's it. That's all there is to it. Okay, now if you look at the next problem, the same question, where would a secant have a vertical asymptote on this same interval? So we're going to look at that. Well, the one thing that you got to remember is what is the definition of a secant? So the secant of some angle theta is r over x. So the question becomes, if I want to make this undefined, I got to know when is x equal to 0? Where on a unit circle is x equal to 0? Okay, that occurs at two places. Like at this point, you'd have the point 0, 1. Okay, that is pi over 2 radians. And then also you would have this point, which would be the point 0, -1. Again, x is 0. So you would have this one would be at 3 pi over 2. So there's be two places. There would be x equals pi over 2. And then there would be x equals 3 pi over 2 like that. Okay, so that's the basic idea is if you're working with a unit circle, you just want to know where things are undefined. You have to know the definitions of the trig functions in order to figure those two things out then. Okay, so that would be the idea on this. So I'm going to draw this coordinate system just real quick one more time and just kind of review what I did on this. So if you look at these places on a unit circle, if you look at 0 radians, you have the point 1, 0. If you look at pi over 2 radians, you have the point 0, 1. If you look at pi radians, you have the point -1, 0. And if you look at 3 pi over 2, you have the point 0, -1. So basically on a cotangent, the cotangent was x over y. So the question is, where is y equal to 0? So y was equal to 0 at 0 and pi. Okay. And then the secant, remember the secant's definition is r over x. So the question became, where is x 0? Well, x is 0 at pi over 2 and 3 pi over 2. That's how I figured that out. Now, the one thing you can't forget is the definitions of the trig functions, certainly. But you can use those definitions in your knowledge of the unit circle to figure out where asymptotes are always, okay? Okay, on this next problem, we're going to do a graph of a cosecant, so I'm going to review that. Okay, so what I'm going to do on this, if we're going to graph a cosecant, okay, the key thing on this is we need to identify all the transformations we have. And really what I'm going to do is I'm going to use a dashed line to graph out y equals -3 times the sine of x plus 2. Okay, now I'm going to show you how to do this just basically in a couple of steps. You can even do this in one step if you want to. Okay, so first of all, you got to identify several things. The period is 2 pi over the number in front of x. So that's just 2 pi. Okay, the increment, we always find the increment by dividing the period by 4. Okay, so that's going to be 2 pi over 4. So that's going to be pi over 2. Okay, so what I'm going to do is I'm going to count this off to pi over 2. This will be pi, 3 pi over 2, and then out to 2 pi like that. Okay, and then I'll do the negatives one like this. So we have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And then a couple of things. Well, we have an amplitude change. Okay, you have an amplitude on this of 3, and then you have a up 2 thing. So you probably want to make this go at least up to 5. Okay, so I'm going to take my y-axis. Let's go 1, 2, 3, 4, 5. And then let's go down 1, 2, 3, 4, negative 5 like that. And then that'll set up what we need to have. All right, so what I'm going to really do on this, now you can do this in more than one step if you want to. So I'm just going to take like, like a color, kind of a light color, like a green or something like that. And I'm going to graph out the sign. I'm just going to pretend like we have y equals sine x. Okay, I mean, we know that a sine x starts at 0, 0, then it hits its height, then it cycles through these points right there. Okay, now you can bypass writing this down if you want to, but it will kind of make it beneficial because in one more step, I can handle these translations. Okay, so notice how the y values go. The y values just go 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0, over and over again forever. All right, well, but what we're doing is we're doing the graph of negative 3 sine x plus 2. So all that's going to happen on this is you're going to multiply the y value by negative 3 and then add 2 to it. Okay, so I'll just do a couple of these. I'm not going to crunch every single one of these out, but we'll do some of them. So if we were to start here, we would do negative 3 times 0 plus 2. So that's equal to 2. So that new point would be, and I'm going to do this in red, that new point would be up 2. Okay, because again, we're graphing negative 3 sine x plus 2. Okay, and I'm going to do this with every single one of these things. So now I'm going to go for this, negative 3 times 1 plus 2. That's negative 3 plus 2, so that's negative 1. Okay, so let's go to y equals negative 1, like that. Okay, and you can just kind of scratch these things out, or you can even erase those if you want to as we go with an eraser. Okay, then we move on to the next one. The next one's just going to be negative 3 times 0 plus 2, which is going to be 2 again. Okay, so this point right here is going to move up to 2. Okay, and then this one is going to go like this. This is going to go negative 3 times negative 1 plus 2. So that's going to be 3 plus 2. That's going to be 5. So this point right here moves all the way up to 5. So what's happening on this is this thing stretches down to negative 5, or down to negative 3 because of the period. Then it reflects. Then it goes up 2. So just think of that stretching to the amplitude of 3, reflecting to there, and then going up 2. Now see, that's enough points that you can see where the min, max, and midpoint are now. So the rest of them, you just predict where they're going to go. This one's going to go to 2. This one's going to go down to 1, negative 1. Okay, this one's going to go back up to 2. This one's going to go to a max of 5. And this one will go back to the midpoint like that. So you just sort of crunch those things out one by one. Okay, then you're basically ready to get your cosecant graph. So all these little green points right here, you can take those off now if you want to, because all those things were just graphs of y equals sine x. Okay, now the next thing we want to do is we want to identify the asymptotes. The asymptotes are always going to occur at midpoints. The midpoint is halfway between the max and min. So all these things right here that I'm highlighting are midpoints. So you're going to have vertical asymptotes through that. So I'm going to just draw go ahead and draw all of my vertical asymptotes through these points. And then I'll be ready to sketch in the final graph. So the y-axis is an asymptote. So you want to be sure you draw that in like that. This is an asymptote. And this is an asymptote like that. And then we'll sketch in the graph like that. I'm going to pick kind of a color. Let's do like a dark green or something like that. So then that's going to do that U shape, kind of like that. That's going to do the U shape like that. Again, you're approaching the asymptotes, but you're not touching them or crossing them. So that approaches the y-axis, approaches that asymptote, and so forth like that. Okay, so that's the graph like that. Okay, so you want to kind of review how I did that then. Now, the other thing that I think is a pretty important thing to do, I'm going to erase a couple of things here and just remind you kind of how you could do a check. So if we wanted to check the answer to this problem, so we just got through graphing y equals -3 cosecant of x plus 2. Now you can pick any point you want to, and it doesn't make any difference. If you wanted to pick 3 pi over 2 and make sure that that y value was 5, you could do that if you wanted to. So let's do that. Okay, we got -3 cosecant of 3 pi over 2 plus 2. If you looked at a unit circle at 3 pi over 2, which is that point, the value of that is the reciprocal of, it's basically going to be r over y. So it's r1 over -1, so it's -1. So this thing right here is going to be -3 times -1 plus 2. That's 3 plus 2, so it's 5. So it matches with that. And you can do the same thing for any of these points. I recommend on a test that you at least choose to check about 2 points to make sure you're right. And students just don't do that. And boy, you need to do that. You can tell you're right on a graph. Take advantage of that. Okay, now, next thing we want to do is want to look over the inverse trig functions. The thing that's real important about these is you got to understand the ranges. So an inverse cosine, the range is on the closed interval 0 to pi. So the answer to this problem must be between 0 and pi. It's got to be. You can't give me an answer outside of 0 pi. The inverse tangent has a range that is an open interval, -pi over 2 pi over 2, like that. Okay. So that means the answer to this problem must fall within those two numbers. Okay, and then the range of the inverse sine is almost like the inverse tangent, except it's a closed interval. Okay, so you can have pi over 2 and -pi over 2 as an answer. So just be sure that when you give these answers, that you're given these things in the correct range. Okay, and then basically these problems boil down to just doing a unit circle. Okay, so I'm going to erase these things. Those were just kind of reminders. And what I'm going to do is let's graph just kind of a basic unit circle, just getting enough points to figure this out. Okay, one thing that you'll have on this test is I'll give you a blank unit circle, but I don't grade it. So let's start with inverse cosine. This is an inverse cosine of a positive number. Okay, inverse cosine's answer goes from 0 to pi. So you're either going to be in quadrant 1 or you're going to be in quadrant 2. If you have a positive value, that's going to put you in quadrant 1. So you need to look on the unit circle in quadrant 1 and find the point that has an x value of square root of 2 over 2. Because remember what this is really saying is it's really saying the cosine of some angle theta is equal to square root of 2 over 2. So you're looking at where that x value is square root of 2 over 2. So you'll have the point on the unit circle, which is this, and that is a 45-degree angle. Okay, but in terms of radians, that's going to be pi over 4. If you don't know that, you can take 45 times pi over 180 and reduce it. So that's the answer. Okay. Now, if I did this same problem, but it was the inverse cosine of negative square root of 2 over 2, then you would be over here with a 45-degree reference angle, so it would be 135. Okay. And then you could convert that to 3 pi over 4. All right, now we're going to look at a tangent. Now, a tangent, the answers to a tangent, and I'm going to go through and erase these two things like this. The answers to a tangent fall between negative pi over 2 to pi over 2. So our answer to this problem is either in quadrant 1 or quadrant 4. Okay, this is a negative value. So that means we can't be in quadrant 1. We have to be in quadrant 4. Okay, so we got that. Now we just need to figure out which point would give a tangent that's equal to negative 1. And remember, the tangent is y over x. So that would have to be a point on the unit circle where x and y are the same. So that would be the point square root of 2 over 2, negative square root of 2 over 2, like that. Okay? So in terms of a reference angle, that is a 45-degree angle. Okay? You also could have 315, but the 315 is out of range. Okay, so this has got to be between negative 90 and 90, so you can't give me that answer. The only answer you can give me is negative 45 or negative pi over 4, because it has to fit in that range. That's the thing that you have to study and make sure that you're aware of, is on a tangent, an inverse tangent and an inverse sine of a negative number, you have to give a negative angle. That's the only thing that makes any sense. Okay? Okay, so let me erase this, and now let's look at what we got going on the inverse sine here. Let me just erase that whole thing and start over again here. Okay, so I'm just going to make a unit circle diagram again to kind of make us reason this out. So here's what you do, basically. We have a negative value. The range is from negative pi over 2 to pi over 2. So we're either in quadrant 1 or we're quadrant 4. Okay, we're going to be in quadrant 4 because of the negative. Okay, so what we need to do on this is we need to look on the unit circle, and the sine is the y value, so we got to figure out which point has a y value of negative square root of 3 over 2. Okay, so what I'm going to do is I'm going to look at it like this. These points right here go like this. This is the point square root of 3 over 2, comma, negative 1/2. This is the point square root of 2 over 2, negative square root of 2 over 2. And then this is the point 1/2, negative square root of 3 over 2. Okay, so that means that that would be the angle where the sine would have that y value like that. Okay, so we just need to figure out what that angle is. Okay, this is going to be a 60-degree reference angle. This is like negative 30, negative 45, negative 60, and you do have to give a negative answer so it'll fit in this range. So that's going to end up being negative pi over 3. Okay, so you want to be sure you study those things, and you have to have these things right here memorized. Okay, I don't give those to you. They're very important to know. Okay, all right, looking now at this one, we're going to do a graph, and this one's got a phase shift on it like this. So let's take a look at what we got on the graph here. Okay, first of all, the amplitude is going to be this number right here. Okay, and remember, an amplitude's always a positive number. So if that was negative 1/2, amplitude's 1/2. Okay, the formula for the period is 2 pi omega, and omega is the value, the coefficient of x. So what you would do on this is you would do 2 pi over 2, so you get pi. Okay? Now, if we do the increment of the x-axis, I'm going to jump down here, that's always the period divided by 4. So the period's pi, divide by 4, you're going to have pi over 4. So we're going to break our x-axis, we're going to make it increment by pi over 4. Okay? Now the phase shift is going to be this number. Now notice this is in a factored form. The 2 has been factored out, so that means automatically that you're going to have a phase shift of pi over 4, and since that's a minus sign, that's going to phase shift you to the right. Okay, and then this number right here is your vertical translation. That's what up 1 is going to be. Like that. So we've got everything kind of recognized. Now we're going to build a graph out of this then. All right, so I'm going to kind of put this at the side. We're going to be graphing y equals 1/2 cosine of 2 times x minus pi over 4 plus 1. And let me show you kind of how I've been trying to get you guys to do the graphs, just maybe in 2 steps. Okay, so what we're going to look at is we're just going to look at this part of the graph right here. Okay, we're not going to look at the amplitude, and we're not going to look at the up 1. Those are things that affect y values, so we do those last. So what I'm going to do is I'm just going to graph y equals, and I'll do this like in a dashed line, y equals cosine of 2 times x minus pi over 4. So what we need to do is we need to go ahead and get our coordinate system built up here. So we're going by an increment of pi over 4 is what we figured out there, as that's our increment. So we're going to go 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and maybe out to 5 pi over 4. Okay, I just want to get 5 key points. We do have an amplitude of 1/2, so we probably need to take this thing maybe up to 2, down to -2, something like that, and then these will just kind of be, that'll be 1, -1, then we can have 1/2. We can go ahead and break those up into halves like that. Okay, so what we do is when you have a phase shift, this is real important, is you want to start at that phase shift. So here's kind of what we do. Now I'm going to do this kind of like this. I'm going to take just kind of lightly the cosine. Remember, the cosine graph goes like this. Starts high, then it goes like this, hits a minimum, and so forth like that. All right, now all we're doing on this is we're going to phase shift this thing to the right like this. So this thing moves over here. So that new point is going to go here. So you can forget about that point now. This one also phase shifts to the right, pi over 4, so it goes there. So you can do that. This one also phase shifts, so you can forget about that, and so forth. Okay, once you get a few points, then you can easily predict where the rest of them go based on your knowledge of the cycle. Okay, so it's going to go like that, and then this point would go back down like that. Okay, so all I did is I phase shifted a basic cosine. This thing right here is built into this increment change. So just by doing that increment change, we've taken care of that period change. We just need to start at the phase shift, okay? So what do we have on this now? The y values we have are 0, 1, 0, -1, 0, 1. So now is where we look at these two numbers, 1/2 and +1. So the way you handle this is you go like this. You go 1/2 times 0 plus 1. Okay, if you do that in your head, you're going to have, that's equal to 1, so that point, you're going to end up being there. Okay, do the same thing here. You're going to do 1/2 of 1 plus 1, so that's going to be 1/2. So this point right here moves up to 1/2. Okay, like that. Okay. And then this one, you're back to 0. So that would be 1/2 times 0 plus 1. So that is going to be back to 1. Okay, this one you have -1. So that's 1/2 times -1 plus 1. So that's 1/2. That's 1 minus 1/2. So that's 1/2. Okay, so this point right here is going to move to 1/2 like that. Now that is a positive 1/2 like that. When we have that one put together then, okay? So that one gets moved up to that point right there to 1/2. Stop that. Okay? All right? And then this point would again be 1/2 times 0 plus 1. So that's back up to 1. Okay? And then this one would be, has a y value of 1, so that would be 1/2 times 1 plus 1. So that would be back up to 1/2 like that. Okay, so now if I went through and just drew this in a graph, it would go like this. Okay, it will just kind of go through these points like this, kind of snake its way through those points like that. That would be your answer. Okay, so again, start at the phase shift. You've already got the increment changed on the x-axis to do that. And then just your y values. See, if you only do this part right here, your y values are going to follow what they do on a basic cosine. And then this is multiplying y by 1/2 and then adding 1. And that's how that would go then, okay? And then you can check if you want to. So pick a point. You know, if I were doing this, I'd pick pi over 4. So let's just say, okay, x equals pi over 4. Okay, what do we have? We have y equals 1/2 cosine of 2 times pi over 4 minus pi over 4 plus 1. I use pi over 4 because it's so easy. So this is 1/2 cosine of 2 times 0 plus 1. So this is 1/2 of the cosine of 0 plus 1. Well, the cosine of 0 is 1. So this is 1/2 times 1 plus 1. So that's just going to be 1.5. So notice that point did have a y value of 1.5. So you can check like that. I think that's an incredibly important thing to learn how to do on this test is check your results. Okay? Okay, now this would be a kind of an automatic answer on this one. You can reason this problem out like this if you want to. So basically, if you're doing an inverse cosine, okay, remember that the range of an inverse cosine is on the interval 0 to pi. Okay? So since there's a negative, that's going to put you in quadrant 2. Okay? 0 to pi is that. So that's a negative value for the cosine, so that's going to put you in quadrant 2, okay? And then basically what you have is you're going to have x is going to be negative 10, and then you're going to have y is equal to 13. Well, what you're doing on this problem ultimately is finding a cosine, and a cosine's x over r, so it's just negative 10 over 13. So the answer to that problem pretty much automatically is going to be negative 10 over 13. Okay, anytime you do a trig function of the inverse in this order like this, then that will be your answer right there. Okay, you do it backwards, though, it's a little bit different. Okay, the next one is probably a cosine sum difference identity. So what I would start with on this one is just take 180 over 12. Remember, you can't use a calculator on this, so you want to be kind of careful about how this goes. So we'd do 180 divided by 12. That goes in 1 time. 6 left over. 12 into 60, 15 times. Okay, so that's going to be just 5 times 15, which is going to be 75. Okay, so what we're really going to do on this problem is we're going to do the cosine of 75 degrees. Okay, all right, so let's write that down. Cosine of 75 degrees. We need to find 2 angles that add or subtract to 75. The logical choice is 45 degrees plus 30 degrees. Then you got to know your cosine identity. So your cosine identities go like this. If you had like alpha plus beta, it goes cosine alpha, cosine beta, minus sine alpha, sine beta. Okay, and then if you had cosine of alpha minus beta, that goes cosine alpha, cosine beta, plus sine alpha, sine beta. Okay, so I just remember this identity. The cosine identity goes cosine, cosine, sine, sine, different sine. Cosine, cosine, sine, sine, different sine. So I don't give that to you. You have to remember that. Okay, so when we do this, we're going to have cosine of 45 degrees times the cosine of 30 degrees. Different sine minus sine of 45 degrees times the sine of 30 degrees like that. Okay? All right, so now what we need to do is just kind of pull out the unit circle or your special triangles. It's up to you which way you do. I just do unit circle on this. So what I'm going to do on this then is just go back to a quick little unit circle diagram on here and just figure out these key points. Okay? So we're in quadrant 1. We have a 30-degree angle there, a 45-degree angle, and a 60-degree angle here. Okay? All you need to do is just do the points. This x value is over as far as possible, so that's why you have the 3 there. It's up as little as possible, so that's a half. And then this point would be square root of 2 over 2, square root of 2 over 2. So you've got to be sure that you know how to do those values. Okay, so the cosine of 45 is just going to be the x value. Okay, the cosine of 30 is going to be the x value of that point, like right there. So we're going to go ahead and just put those together. So this is going to be square root of 2 over 2. Cosine of 30 is square root of 3 over 2. minus, now when we do the sine of 45 and the sine of 30, those are the y values. Okay, so when we do that, we're going to have square root of 2 over 2, and then 1/2 like that. So that will be square root of 6 over 4 minus square root of 2 over 4. You've already got a common denominator, so you can write the answer like this. So your final answer is square root of 6 minus square root of 2 over 4, like that. Okay? So that is a cosine sum difference identity that you have to know. I don't give those to you, so you want to be sure that you study those then. Okay? All right. So the next thing we want to look at is the sine. And the thing on this one again is a sum difference identity. So we're going to go ahead and write the sine of negative 15. You have two choices. You could either say 30 minus 45, or you could say 45 minus 60. I'm going to go, just for something different, I'm going to go 45 minus 60. It'll work either way, though. Okay? Now, your sine sum difference identities go like this. So I'm just going to write them down, then I'm going to erase them. But just to remind you how these go, they go sine of the first, cosine of the second, same sine, cosine of the first, sine of the second. So it goes sine, cosine, cosine, sine, same sine. This one would be the same way. This would be sine alpha, cosine beta, same sine, cosine alpha, sine beta. Okay, like that. So when we're expanding this, it's going to go like this. We're going to do the sine of the first angle, 45 degrees, times the cosine of the second angle, 60 degrees. We're going to use the same sine. Then we do this backwards. We're going to do cosine of 45 degrees, and then we're going to do times the sine of 60 degrees like that. Okay, now it's just a matter of unit circle knowledge here. So I'm going to draw another unit circle, and we'll take a look at how that goes. Okay, so we just need to look at 45 and 60. So again, we're in quadrant 1, and we have these points right here. Okay, so here's the way that I figure these things out. Is this thing has the biggest x value possible. This has the smallest x. So this is going to go 1/2 square root of 2 over 2, square root of 3 over 2. Then the y's get bigger this way. So that's going to go 1/2 square root of 2 over 2, square root of 3 over 2. Okay? So what we're going to do is we're going to start by doing the sine of 45, which is that y value. So that's going to be square root of 2 over 2. Then we're going to do the cosine of 60, which is that x value. So that's 1/2. Then we're going to do the cosine of 45. So that would be that x value. Okay, so that's going to be square root of 2 over 2. And then finally we'll do the sine of 60, which is this y value. So that's the square root of 3 over 2. Okay, and then you're going to have a very similar looking answer. This is square root of 2 over 4 minus square root of 6 over 4. So the final answer would be square root of 2 minus square root of 6 all over 4. And that's it. Okay. So if you know the identities, know your unit circle, those aren't too hard to do. Okay. All right. Now this problem I put on here has something to do with the tangent identity. So partially, you need to be sure that you know your sum difference identities for sine, cosine, and tangent. Okay, now I'm going to write down at the side what these identities are. So if you had the tangent of two angles, alpha plus beta, that's equal to the sum of the two angles all over 1 minus the product of the two angles. Okay, and then if you had tangent of alpha minus beta, that's going to be tangent of alpha minus tangent of beta all over 1 plus tangent of alpha times tangent of beta, like that. So see, what I've done is I've given you the right side of an identity. And since this has a plus there, that matches there. And since it has a minus there, that matches there. So that means this is going to be the tangent of alpha plus beta. So you're just doing this in reverse. So this is going to be equal to the tangent of the first angle, which is pi over 15, plus the second angle, 4 pi over 15, Okay, so if we work that out, that's going to be the tangent of 5 pi over 15. So that reduces down to the tangent of pi over 3. Then you need to just go to your unit circle and figure out what that is, or you can even look at a triangle if you want to. That's really 60 degrees. So you could just on this problem look at a 30-60 right triangle. Here's 60, here's 30, here's 90. So it goes 1, 2, square root of 3. The tangent is opposite over adjacent, so it would be square root of 3 over 1. So that means the answer to that problem is square root of 3. Now you could also go to the unit circle and just do y over x if you want to get the answer. Okay? All right, let's see. Next page, let's see what we got going on this problem. Okay, so this problem, first of all, the first thing I'm going to look at is inside the parentheses. And there's a couple of things that this tells us. Okay, the first thing it tells us is if we're doing an inverse sign, y is going to be the numerator, r is going to be the denominator. So what we're going to have is we need to figure out what x, y, and r are in this problem to solve it. So we know that y is -3, and we know that r is 5. Okay? The other thing is we have an inverse cosine. So the inverse cosine's range is on the interval -pi/2 to pi/2. Now that's real important. Since this is a negative, remember your range on an inverse cosine or inverse sine goes either in quadrant 1 or quadrant 4. Since that's a negative, you're going to be in quadrant 4. Okay, so that means x is going to be a positive value, and then you can go the Pythagorean theorem, so x is going to be equal to 4. Okay, so that's what you do on the problem to begin with. Now, if you kind of go back and begin to look at the problems on here now, we're now looking at the cotangent. Well, the cotangent is x over y. So the answer to this problem would just be whatever x over y is. So that's going to be 4 over -3 or -4/3. So that's your answer to your problem. -4/3, okay? So you'd be expecting something kind of like that. Okay, now we're going to get into a little bit of the trig equations. Okay, so the trig equations work like this. First thing we want to do on this one is you're going to find all real numbers in this interval. So you're going to give me every answer from 0 to 2 pi. So we're going to, first of all, start by isolating this cosine. Okay, a lot of this we can do in our head. So what we're going to do is this is going to be 2 cosine of x equals -1. Then I can divide by 2 to get cosine of x equals -1/2. Okay, so now what it is it's just an interpretation of the unit circle again. So the idea is going to be, where is the cosine negative? Does it have negative values? Well, cosine's negative in quadrant 2 and quadrant 3. So again, you got to figure out, well, where is the reference angle that I'm looking at? So you would have to figure out where x is -1/2. So if you looked at these points on the unit circle, and this quadrant, they'd basically go like this. This point right here would be -1/2, positive square root of 3 over 2. This would be -√2 over 2, positive √2 over 2. Then this one would be negative square root of 3 over 2 and 1/2. Okay, so that means that we're looking at that angle right there. That's a 60-degree reference angle. So that's going to be 120 degrees. Okay, so one of our answers is going to be 120 degrees, but we have to convert it to radians. Now all that's going to mean is the second angle is going to be in quadrant 3, and it's going to have a 60-degree reference angle. So that's just going to be 180 plus 60, or 240. Okay, like that. So we're going to have these two answers that need to be converted to radians. Now, if you did your unit circle at the beginning of the test, then you would have all this taken care of, so you wouldn't have to do this. So I'm going to multiply that by pi over 180, and that gives 2 pi over 3, so that's one answer. And then I'm going to multiply 240 by 2 pi over 180, and that gives 4 pi over 3. So the answers to this problem are 2 pi over 3 and 4 pi over 3. So you write that in a system a set builder notation like that. So that's the idea. Okay, now if we go down to this number 14, this one you already have a trig function that's isolated. So this would be an example of a problem. If you want to change the tangent squared to a tangent, you would have to take the square root of both sides. And when you take the square root of both sides, one of the things you want to be sure that you do is that you have a plus or minus in front of that radical 3. So what you're going to have is this is tangent of x. This is equal to plus or minus the square root of 3. Okay? So basically, you're going to have an answer in every quadrant on this problem. And again, you're looking for all the real numbers that are in this interval. So if we were to go through and draw out a unit circle diagram on this, now we can do triangles too. A lot of times I tell you guys on tangents, a lot of times I prefer to do triangles because the tangent is opposite over adjacent. So if you have square root of 3 over 1, that would be a possibility. So that would be 60 degrees. And that's all we need to know on this problem is 60-degree reference angles. So you're basically going to have, at this point, you're going to have, that would be root 3, but that would be negative 1. And then if you went to quadrant 3, you'd have a 60-degree reference angle with this being negative root 3, like that. And then if you went to this one, you would have a 60-degree reference angle having those values like that. So if you were going to do this in degrees, then it would just go like this. Okay, you would have 60 degrees. Okay, then we would have 120 degrees. Then you would have 180 plus 60, or 240 degrees. And then you would have 360 less 60, or 300 degrees. Okay, or if you already have your unit circle put together, you just look it up. Okay, and then if we convert these to radians, 60 pi over 180 is going to give you pi over 3. So that'll be the first answer. Okay, and multiply this by pi over 180 and reduce. That's going to be 2 pi over 3. Okay, and then multiply this by pi over 180. That's going to be 4 pi over 3. And then finally, this one, if you multiply that by pi over 180, let's see, that's going to be, I think, 5 pi. Let's see, you can cross out the zeros, divide by 6, so you'd have 5 pi over 3 on that, okay? So you got 5 pi over 3. Okay, and then those should be the 4 answers of that problem. So that's a square root property. Primarily is what that is then, okay? Okay, so notice they just have 60-degree reference angles all around. The plus or minus is what generated 4 answers, okay? All right, now this trig equation right here is going to require an identity. Okay, so we've got 2 cosine squared x plus sine of x minus 2 is equal to 0. Okay, now one thing I notice on this is we have 2 trig functions. However, we have the identity sine squared x plus cosine squared x equals 1. So we could solve for the cosine. We could move this to this side to get cosine squared x equals 1 minus sine squared x. So what I'm going to do is I'm going to replace that cosine with this. Okay, so I'm going to write this down like 2 times the substitution plus sine x minus 2 equals 0. So I'm going to plug this thing in like that. Now see what we've accomplished by doing that now is we have one trig function. We just have sines. So now I'm going to do a distributive property. So that's 2 minus 2 sine squared x plus sine x minus 2 equals 0. Okay, the 2's cross out, which is kind of nice, and then you're left with negative 2 sine squared x plus sine x equals 0, and you got to solve this by factoring. So you've got a common factor of sine x that you have to pull out of this then. Okay, so sine has to be multiplied by negative 2 sine x to get the first term. See, that times that checks to this, and then sine times 1 is going to give sine x. So if you factor something, make sure that you did it right, okay? Because if you didn't, you're just kind of wasting your time finishing the problem. So now we're going to set these two factors equal to 0 to finish up the problem. So we're going to do sine x equals 0. That'll have something to do with the unit circle. Then we're going to solve negative 2 sine x plus 1 equals 0. And again, that's going to have something to do with a unit circle also. Okay, so let's go ahead and see kind of what we got going on the unit circle on these two problems then. Okay, so if we look at the sine of x equals 0, okay, now we're going to solve this equation again. It says I want to solve this equation on this interval. All right, so we need to do this. Okay, so the idea is going to be, where is the y value equal to 0? Okay, one place that you're going to have a y value equal to 0 is at the point 1, 0, and another place is the point negative 1, 0. Okay, so those will be two places where the sine x equals 0, so that's going to be x equals 0 and pi radians. So those will be two of the answers to the problem are 0 and pi. Okay, now we need to solve this equation, so this is going to be you could just say negative 2 sine x equals negative 1. You could divide by negative 2 if you want to, so that gives sine of x equals 1/2. Okay, now what I'm going to do on this, again, it's just a little unit circle diagram to help us reason that out. So we're going to look at any place on the unit circle we can think of where the sine is equal to 1/2. Okay, first of all, the sign is positive in quadrants 1 and 2. So you've got to be in quadrant 1 or 2. So let's just figure out of these 3 points right here, which one has a y value of 1/2. It's going to be the one that's the lowest, because this is going to be a square root of 3 over 2, 1/2. So basically, this would be an angle where the sine would be 1/2. That's 30 degrees. Okay, and then if you go over to this point on the unit circle, this point on the unit circle is negative root 3 over 2, 1/2. So that also has a 30-degree reference angle. So our angles are 30 degrees, okay, 30 degrees, 150 degrees, and then we can convert those two things to radians, okay? So I'm going to multiply that by pi over 180. That'll give me pi over 6. So that'll give another answer, pi over 6. What's going on with this thing? Pi over 6. Okay, and then if we multiply 150 times pi over 180 and do the reducing, that's going to be 5 pi over 6. Stop that. Okay, so it's going to be 5 pi over 6. So those would be the 4 answers to the problem on that are 0 and pi over 6, and 5 pi over 6 like that. Okay? So again, this revolved around factoring, and then once you did the factoring, you had to ultimately analyze those two statements right there on the unit circle to get the answer, okay? Okay, now on, let's see, on this one, this says write the equation of a cosine function with the following graph. Okay, so this is kind of like something that you did a little bit on the, what's that? The pendulum problem, the swinging ball problem that we did. Okay, so first of all, the general formula is going to be y equals a cosine of omega x minus phi for the phase shift, and then some other number like for the up-down translation. So we got to figure those things out. Okay, I don't know why it keeps doing this. Jeez. Okay, so we're going to figure that out. The first thing we want to do is let's figure out what the amplitude is. The amplitude is actually very easy because the amplitude is 1/2 the distance between the max and the min. Okay, so when we do the amplitude, that's going to be 1/2 the max minus the min. It's a distance, so that's why I'm using absolute value. So that's going to be half the max. The max is 5. The minimum is negative 1. And you can do this by counting too if you want to. So that's a half of 5 plus 1. So that's half of 6. So that's going to be equal to 3. So the amplitude is going to be 3. So that's what goes there. Okay. So now what we got to do is we got to figure out the period. And to figure out the period, that will ultimately help us to figure out what omega is. So our next strategy on this is try to figure out what omega is. Okay? All right, the period would be, let's just start here and look at this point right here. And then the cycle's going to go 1, 2, 3, 4, 5 key points. So that's going to be the end of a period. So the period on this seems to be 4 units. Okay? So we're going to have use this equation. Period is equal to 2 pi over omega. Okay? So the period, we just crunched out the period on this to be 4. So we're going to say 4 equals 2 pi over omega. I'm going to cross multiply, so that's 4 omega equals 2 pi. Then I'm going to divide by 4, so I get omega equals pi over 2. That's what goes there. Okay? All right, so we got that. When we put that together, now we need to see if we have a phase shift or not. Now, we're supposed to do a cosine on this, so there is no phase shift. And the reason there's no phase shift is because the cosine starts high, so that's just going to be 0. Okay, like that. Now, if you want to figure this thing out, the best thing to do is to look at the midpoint. Okay, so the midpoint on this, see, the amplitude is 3. So if you went from this minimum and went 1, 2, 3, this would be a midpoint right there. So how high has that midpoint gone up? Okay, it has gone up 2 units. It's easiest to see those midpoints and how they go up. Okay, so that thing is going to be up 2. So now we're ready to write the answer. So our final answer is y equals the amplitude 3 times the cosine of omega, or pi over 2 times x. And you don't have to put the minus 0 because there is no phase shift. And then plus 2. Like that. Okay? And that's it. That should analyze everything. A couple of things you want to know is this formula gives you the amplitude. This formula gives you omega. And you should easily be able to count the amplitude and count the period on any graph I give you. And then I always recommend for the up-down step that you look at the midpoints, okay, of the graph. And then phase shift would be, well, you know, I knew there was no phase shift because the cosine wave starts at the maximum point like that. Okay? Okay, so that'll take care of that. You want to be prepared to. Okay, so let's see. Let's move down to this last page here, and let's do a couple of proofs. So another thing you'll have to do on your test is be able to do some proofs. Okay, now one of the things is your proofs have to be written a certain way, or I'll take points off. So I'm looking for you to write a side, have a bunch of equal signs, just keep things down until you get the other side. So that's the structure. Nothing else on these problems is acceptable. So we're going to start this like this. We're going to pick a side and write it down. Usually we pick the most complicated side, like that, and just kind of use fundamental identities. Now I can give you all kinds of proofs. Generally I give what I would consider a simple proof and a more moderate level one. Nothing real advanced just because of the time pressure. So what I'm going to do is do a distributive property. So I'm going to do cosine theta times tangent theta. So let's write that down. Then I'm going to do cosine theta times cotangent theta. Also, don't lose your thetas. So like if you wrote cosine cotangent, I'd take off a point. Okay, you cannot lose those thetas. That drives me crazy and other math teachers. You don't be lazy about that. Keep writing the theta down. Okay, now what we're going to do is we're going to use an identity for this, an identity for that. And then we're going to see what comes out of this thing then. Okay, so we're going to bring down an equal sign. You have to do that. So we have cosine theta. The tangent we know is the sine theta over the cosine theta. Then bring down the rest. That's going to be cosine theta. And then the cotangent we know is the cosine theta over the sine theta. Okay, so a couple of things that you'll have going on this problem then is, well, those cross out. So that's going to leave you for the next step. You're going to have equals sine theta. And then this part right here, if you put that over 1 and multiply, you're going to have cosine squared theta over sine theta. Okay, now keep bringing down the equal sign and just kind of show the steps. Well, the next thing we need to do is we need to get a common denominator. So you would want to show that what you're going to do is multiply the sine theta by sine theta over sine theta in order to introduce that common denominator. Then bring this down as cosine squared theta over sine theta like that. Okay? All right, so now what do we have? We have sine squared theta over sine theta plus cosine squared theta over sine theta. Now I'll just keep kind of taking it this way. So now you're going to have sine squared theta plus cosine squared theta over sine theta. You get a common denominator. However, we know this is 1. So you have 1 over sine theta. And then 1 over sine theta is the cosecant of theta. And that's what we're trying to prove. So what I'm trying to look at structurally on your proof, you pick a side. You had a bunch of equal signs. You never lost those equal signs. And you ended up with the other side. I don't want to see the proofs any other way. It's got to have that structure. And don't lose the thetas and the u's and whatever variable that we're using for the x values. Okay, or for the angular values. Okay, so on this one, pick a side. I think it's probably easier to go with the right side. I mean, you could try it either way. I'm sure you could get it going either way. So again, just pick a side, write it down, and then put an equal sign. So what I'm going to try to do on this is I'm going to try to go through and maybe multiply by the conjugate or something. I don't think I'm going to get much of anywhere unless I multiply by a conjugate. Okay, so I'm going to try that. Now this is a little bit more advanced level proof. So sometimes these are good ideas, is just to try to multiply by a conjugate because it gives you more options. When you start getting a sine squared and a cosine squared in your expression, it kind of gives you more options. So let's see what happens. So what we're going to have in the numerator is cosine u times 1 plus sine u. We may have to multiply that out. And then the denominator, we do need to multiply that out. And if you do that by FOIL, you're going to have 1 plus sine u minus sine u minus sine squared u. Okay, so we're going to do that. Now let's go ahead and just bring down the numerator and just keep doing that. We may have to multiply it out. We'll see. And then the denominator is going to be 1 minus sine squared u. Okay, so now let's kind of think about what's going on this problem. We got to prove that it's equal to a secant u plus a tangent u. So one thing I see here is I see this. Now, any of your scratch work I do not need to see, but at the side of the paper, I'm just going to remind you that the sine squared of u plus the cosine squared of u is equal to 1. So if I moved that sign over there, I'd have cosine squared u equals 1 minus sine squared u. So that means this thing can be replaced with this thing. So I would get cosine of u times 1 plus sine of u. Then I'm going to replace this with cosine squared of u. Okay? And then we'll have to see if anything comes out of this, basically. So let's go ahead and multiply out the numerator now. So we're going to have cosine of u plus cosine u sine u all over cosine squared u. Now what I would do at this point is I would split this up into two parts. So I'm going to have cosine u over cosine squared u plus cosine u over sine u all over cosine squared u. Okay? Now, if you do this, one of these things is going to cross out. So if you have a cosine over a cosine squared, in your mind, you can just kind of write it out like that. That's going to be 1 over cosine. And then one of these is going to cross out, leaving u plus sine u over cosine u. Okay, well, this is equal to the secant. And this is equal to the tangent. And I think that's what we're trying to prove. Okay, indeed it is. Okay, so the idea with this proof now, okay, again, you pick the side. You just kept substituting equals for equals. like this. I'll squeeze this out a little bit so you can see the whole proof. Like that. And then we ended up with this side. Perfect, beautiful proof. Now you might be able to do that in less steps. So that's more of a intermediate level to advanced level proof. There's enough steps that one's, pretty, it's not a real complicated one, but it's a pretty challenging one. Okay, like that. Okay, so that will finish up this part. I'm going to go ahead and stop this recording. And then that should give you a good sample of some of the types of things that you're going to have to know how to do.